In this video, we are looking at how can we use trigonometric formulas. These are the formulas that you'll find on the reference sheet that has been given to you and that you will find on the back page of your Regents exam. And the question says, find the exact value of the sine of 210 degrees. I don't know what the exact value of the sine of 210 degrees is, but I do know the exact values for the sine and the cosine of 270 degrees, and I know the exact values of the sine and cosine of 60 degrees, and what I notice is that the sine of 210 degrees must be the same as the sine of 270 degrees minus 60 degrees. Because 270 minus 60 does equal 210. The question is then, is there some formula that lets me find the sine of two angles being subtracted? I want to know, how can I write out the sine of two angles that are being subtracted? And for that, we go to the reference sheet and we look and we try to find some formula that will help us to do that. So you should look through this, be looking around, and what I notice is here, under the difference of two angles, after all, difference does mean that we're subtracting two things, I notice that right on top there's the sine of A minus B is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. And I'm going to write this formula out right here for us to look at. So this is the sine of A minus B is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. Here's the formula that we found from the reference sheet. And now we're going to make these substitutions. See, here's our A minus B, here's 270 minus 60, and so the A is the 270, the B is the 60, so let's make the substitutions now. So this is the sine of 270 times the cosine of 60 minus the cosine of 270 times the sine of 60. So that was our first substitution. We just we changed the A and the B into the actual numbers that we're using. And now we're going to do another nice substitution, because you see, we know these values. These are special angles. 60 is a special angle. 270 is one of the quadrantal angles, so that's very nice and easy to remember. Just to refresh your memory, if you ever need to figure out what are the sine and cosine of the quadrantal angles, well, these are the quadrantal angles. This is 0 degrees. Here's another quadrantal angle. This is 90 degrees. Here's another quadrantal angle. This is 180. And right down here at the bottom, this one is 270, and that is also a quadrantal angle. Since it's a unit circle, we know exactly what these coordinates are. This is 1, 0. This one is 0, 1. This one is negative 1, 0. And down here at the bottom, this is 0, negative 1. And so I want to know, what is the sine of 270? Well, the sine of 270, this is our 270, is right down here. The sine here is negative 1, right? Because this is the cosine and that is the sine. And that's our negative 1. So the sine of 270 is negative 1. That's a substitution. Now, how about the cosine of 60? Well, the cosine of 60 is 1/2. That's a value that you should know, since it is a special angle that you're supposed to have memorized. The cosine of 270. Well, here again is our 270. Which of these is the cosine? Oh, of course, it's the x-coordinate. So the cosine of 270 is just 0. And isn't that nice? Because now it makes no difference what this is, since it's going to be just something times 0, just for the benefit of helping you see again. The sine of 60 Well, the sine of 60 is radical 3 over 2, so this is radical 3 over 2, but it's not going to matter because 0 times radical 3 over 2 is 0. And so what do we have here? We have negative 1 times 1/2, which becomes negative 1/2, and then minus 0, so this whole thing is negative 1/2, which means that the sine of 210 degrees is equal to negative 1/2. That is excellent, and that is the exact value. As long as we're at it, I think I'm going to show you another way that we could have found that that's a negative 1/2. Let's use the idea of reference angles, okay? So I'm going to make a unit circle here, and I'm going to estimate where is this 210. Well, 210 is down here in the third quadrant. I would say it's right about here. Right there is it's approximately 210. And the reference angle for 210 is the smallest angle, which takes us back to the x-axis. Now this is the smallest angle. You see, I could go from there to there, but that's a much larger angle than this one. And if this is 210, then what is the size of this angle? Well, from there to there is 180, and there to there is 210. That means that 210 minus 180 gives me the size of this one, and that is 30 degrees. And we know everything about 30 degrees. We know the cosine of 30 degrees is radical 3 over 2. And we know the sine of 30 degrees is 1/2. And since we know the coordinates of this point, we should be able to get the coordinates of this point, right? Because when we go from the first quadrant down here to the third quadrant, this radical 3 over 2 becomes a negative radical 3 over 2. And this 1/2 becomes a negative 1/2. Now, which of these is the cosine and which of these is the sine? You're absolutely right. This one is the cosine, and this one is the sine. And so what is the sine of 210 degrees? Well, the sine of 210 degrees is right there. That is negative 1/2, which is what we expected when we were getting practice doing it the other way.